Hey everybody, Mr. Judson here. So today what we want to take a look at is just things with linear equations. I mean, we did some work with that with our Walmart and basketball problems, but now we're going to kind of go back to a more traditional, let's find the equation of some lines. So first of all, let's just review real quick the things that we want to make sure we know. We know that slope, which we often say, use the variable m for slope, is equal to rise over run, and to calculate that we do y2 minus y1 over x2 minus x1. And we also say that slope represents a rate of change. Okay? And this is really an important idea. I mean, it seems like such a simple thing that we've talked about for years and years, but you know, right now in calculus, we're talking about slope, and we're probably going to be talking about slope for the entire semester, which is like, oh my gosh, that sounds boring. But we do this thing called a derivative, and the derivative means the same thing as a slope, and so it's very closely attached to these ideas. All right, so we've also talked about the different forms of an equation. We've got slope, intercept form, which is y equals mx plus b. In the end, any answer that we find for the equation of a line, this is what we want it to look like, okay? And remember, I told you guys, I don't care if you start off with this. You can if you want. Another form is the point slope form. And that is y minus y1 equals m times x minus x sub 1. I'm going to start with this and work my way towards this one. And again, the only reason is I found that fewer people make mistakes when they do that. All right? Some other information that we just want to remember about lines is that if we have parallel lines, they have equal slopes. And perpendicular lines have negative reciprocals for slopes. So, you know, we'll just kind of do a quick example of this because I think a lot of people somehow remember perpendicular lines have opposite slopes. And the word opposite means positive and negative. You know, the opposite of 4 is a negative 4. The opposite of negative 5 is a positive 5. That doesn't make slopes perpendicular. The reciprocal part means flip the fraction over and then make it the opposite. So if I have a slope that equals a negative 2/3, well then the perpendicular slope, so that's my symbol for perpendicular, is going to equal 3/2. So we just want to make sure we've got that straight as well. All right, so let's start with a practice problem. And I've kind of got this color code thing that I've been using. Anytime I write something in black, that means that's really important information. We want to make sure we get that. All the problems that we work, I'll always do that in blue, and then I'll work them out in red. And I'll just follow that color code all year long, okay? So I want for you guys to find an equation of a line through the points 2 comma negative 3 and negative 1 comma 6. So what I'll do is once I write this problem down, I'll just kind of stand here for 3 or 4 seconds, and then I'll start working it out. You guys won't be able to get the answer that quick. So what you want to do is you want to hit the pause button on the video, go into your notes, work this out real quick. Once you have the answer, then go back and resume the video. All right? So you guys go ahead and try this. All right, so this is really similar to what we did with the Walmart and basketball stuff. It's just our points are easier to work with this time. So first thing I need is a slope. Every time you see that statement right there, equation of a line, we need to think to ourselves, I need a slope and I need a point. Okay? I got 2 points, I just need to get the slope. So y2 minus y1, that'll be plus 3 over x2 minus x1. Negative 1 minus 2. So there we've got 9 over negative 3, which is a negative 3. Okay? There's my slope. And so now to write the equation of the line, I've got y minus the y value. I don't care which point we pick. So I'll go with the first point. So y minus a negative 3 equals my slope, which is negative 3 times x minus 2. And so now I need to distribute that, so I get y plus 3 equals a negative 3x plus 6. And now when I move this 3 to the other side, I do the opposite. So I'm going to subtract 3 from that. So I get y equals a negative 3x plus 3. There's my equation. So just to see that it doesn't matter which point I use, let me go ahead and do this one in a different color. I would do y minus the y value equals the slope times x minus the x value. Go ahead and distribute that, so I get y minus 6 equals a negative 3x minus 3. And then I need to move this negative 6 to the other side and do the opposite. Even though this says subtract 6, what I do is I look at that and I see that as a negative number. Okay, this is a positive number, that's a negative value, that's a negative value. Oops, there we go. So I'm going to move this negative number to the other side and do the opposite. It becomes a positive 6, and so y equals a negative 3x. Add 6 to that, you get plus 3. And I got the same equation. Sometimes people look at that and they go, why does that happen? Like, why, how can that happen? They're 2 different points. Well, remember, if I told you guys to graph this line, let's act like we're way back in beginning algebra. First thing you would do is you would make an XY table over here, and you'd pick some numbers to plug in, and you'd get some values back. And what we get here is a whole bunch of different ordered pairs that make this equation true. That's what happens when we plot a line. We're plotting a whole bunch of points that make that equation true. And so if there's a whole bunch of points in this list, then why can't 2 different points work and give us the same equation, as long as they're on that line, all right? And so that's what we're saying here. These are just 2 of the many points that we would have gotten through that XY table. All right, let's try another problem. All right, so you guys go ahead and try this one. So this one should seem a little bit easier, right? In order to find the equation of a line, I need a slope and I need a point. It's kind of like we're not getting harder, we're getting easier. Is that what's going to happen the whole year? Well, I wish I could say yes, but no, it's not. But they'll ask us problems like this on today's homework. So y minus the y value equals the slope times x minus the x value. So one thing that's a little different here is all of a sudden we've got fractions showing up. You know what? Those are numbers. Fractions, decimals, whole numbers, positive, negative, they're all numbers. And we want to be comfortable working with any of those. Okay? So the process doesn't change. I just distribute that. So I get y plus 2 equals a negative 1/2 x. Negative times a negative, that's a positive 5/2. So whenever you have an integer value times a fraction, really that integer is just 5/1, and when you multiply numerators and denominators. So I always just think of it as integers always go into the numerator, never the denominator, okay? So that'd be a positive 5/2. And so now I need to move 2 over and subtract it. When I do that, I know that's going to go away. I'm going to subtract 2 over here, and I'm just going to write it with that common denominator. Okay, 4/2 is the same as 2, so that way I could say 5 minus 4, that's 1/2. So I've got y equals a negative 1/2 x plus 1/2. There's the equation of my line. Now let's talk about something here real quick. That term right there. This gives people a lot of frustration in my class. Because one thing that's really important to me is I want to make sure we write this so it's very clear to somebody else what's being written there. If somebody walks into our class and all of a sudden we hand a piece of paper and say, do you know what this says? I want them to be 100% sure they know what it means. And so a lot of times I see people write fractions this way. 1/2 and then x. So that's 1/2 times x. And I would say that's not very clear to me. I'm not sure if that's 1 over 2x. It could be. I'm not 100% sure. And so we have to make sure that people who see this understand what we're writing there. Sometimes people go, okay, fine, Judson, you want me to write the fractions that way? Great, there's 2, okay. There's 1/2 x. Well, no, I'm still not sure if that x is in the numerator. Well, actually, to me, it looks like it's in the denominator. Pretty clear. Oh, I've got it. Fine, Judson. Okay, here. Let me just erase this. I'll cut my fraction bar back a little bit. And there. Now, are you happy? Well, no. I'm still not sure. You know, to me, that looks like that x could be in the denominator. God, Judson. Fine. There, now are you happy? Well, no. Is that 1 over 2 raised to the x power? See, I think you need to make that x large enough so that we don't sit there and wonder, is it in the numerator or is it in the denominator? If you want to, you can put it in the numerator. That's okay. Because remember what I just set up here? An integer times a fraction, you multiply it into the numerator. I don't know what x is, but multiply it into the numerator. Same way I did the 5. We want to make sure that we get this. Okay, so let me back up here a second. I'm going to get rid of all this. Oops, no, keep that. I want to make sure that there's no question that I know it's a fraction times a variable. And that variable is not in the denominator. We take our first test, people miss points because of this right here. People will miss points because they don't write down their fraction properly with the variable out, behind it, so it looks like a coefficient times a variable. And you'll get frustrated with me too, everybody does, but it won't take us long. We'll get it. After people get tired of missing half points, and some people it takes longer than others, but every time I see something written like this, and it's not obvious that it's 1/2 times x, because this could be 1 divided by 2x, I'm just going to circle that and go minus 1/2. And for some people they got it right away, they quit doing that, and for some people they quit doing it right around January or February, which means they've missed a half point quite a few times. So let's make sure we get it down right the first time, okay? I think this really has to do with us kind of being sloppy over time and not really having teachers correct us for it. And so I want to make sure we're doing things the right way. I don't want to be added to that list of teachers who didn't correct things, okay? All right, let's try another one. So remember, I told you in calculus, or pre-calculus, we push things a little bit farther. So I want you to find the equation of a line through 1/2, comma 2/3, and 1/4, comma -3/8. Oh my gosh, you gotta be kidding me, Judson. Well, yeah, they're numbers, right? Decimals, fractions, integers, they're all numbers. We gotta be able to work with all of them. So you would do this the same way we did the first one. You guys go ahead and give it a shot. Last time I had to find the slope first, so let's go ahead and do that. Slope equals y2 minus y1, so a -3/8 minus 2/3 over x2 minus x1, 1/4 minus 1/2. Now, you could go through and find a common denominator, add and subtract these fractions, do the same thing down here, and then to do a fraction divided by a fraction, you flip this over and multiply. You could do that, it would work. But one of the things we always look for in math is we look for a quicker way to do things. And the quickest way to get rid of this mess is to multiply top and bottom by the least common denominator. Remember, when you multiply top and bottom by, what is the common denominator here? These all divide into 24, right? I believe so. Everything goes into 24. So if I multiply this by 24 over 24, I'm really just multiplying by a fraction that's equal to 1. So I'm not really changing the value. We've learned this a long time ago. A number times 1 equals itself. So this mess times 1 is going to equal itself, but it's going to look a little cleaner. Okay? I also know that if I'm going to multiply the numerator times 24, I'm going to have to distribute that to each of these fractions. And the same thing's going to happen down here. An integer times a fraction, just distribute it right into the numerators, like on the previous problem. Okay? So usually what I do is, instead of writing it this way, let me back up a little bit, I just do this. Times 24, times 24, times 24, times 24. Okay? And then I'm going to simplify each of these individual fractions. So if I do 24 divided by 8, that's 3, times a -3, that's a -9. Here, 24 divided by 3, that's 8. 8 times 2, that's a -16. 24 divided by 4 is 6, times 1, that's 6. 24 divided by 2 is 12. I really just clean that up quite a bit. And now if I do this, I've got a -25 over a -6. So negative divided by negative is positive. There's my slope. All right? I'll always refer to this as a complex fraction. It means you've got fractions within the fraction. And the easiest way to get rid of a complex fraction is to multiply every single term by that least common denominator. There's my slope. Okay, now I just got to write my equation. So I need to pick one of these points. Doesn't matter which one. I'm going with that one because the numbers are smaller, right? So I've got y minus 2/3 equals my slope, which is 25/6 times x minus 1/2. And now I just got to simplify and solve for y. Get y by itself. So to do that, I'll distribute this. I've got y minus 2/3 equals 25/6 times x. I'm going to make a big, huge x there. When I multiply here, I'm going to get a -25 over 12. And so now I want to move this -2/3 to the other side and add that. So to make it into 12ths, I got to multiply top and bottom by 4 to get my common denominator. So that means I'm going to have a positive 8/12ths when I move this over here. And so my final answer, y equals 25/6 times x Negative 25 plus 8, that'd be a negative 17 twelfths. There's my answer. All right, so even though we're working out of the old book, because right now I had a PDF version of that I could give to you guys, and you would be fine with that. I'm really following the new book, okay? So some of you may wonder, why are we jumping all the way up to page 34? Well, they rearranged the book, they kind of got rid of some things. Our first chapter is kind of a hodgepodge of stuff that I'm not sure all of it's really all that important. Lines are definitely important. We're going to have to deal with those for a long time. So anyway, if it seems like I'm skipping around the book, that's why. I'm trying to follow what our new book does, even though what we have in our hands right now is still the old book. So this is now assignment number 2. Even though we haven't turned in our Walmart stuff yet, this will be our second assignment, okay? It's on page 34 in the PDF version of the book that I gave you guys. I know some of you look at this going, oh my gosh, that's a huge assignment. This is not that big, okay? You just got to know what EOO stands for. So we're doing 5 to 61, and EOO means every other odd. So we're going to do 5, skip 7, do number 9, skip 11, do 13, skip 15, and so on. And so if you want to know how big this assignment is, just do 61 minus 5, 56, and then divide it by 4, because if we're doing every other odd, we're doing every fourth problem. So 56 divided by 4 is about 16. 16 problems of something that we've done before. So that's not a bad assignment. Some of these questions will just ask you about slope, estimate the slope of a line. Some of them they'll show you an equation and say, what's the slope, what's the y-intercept, and you're done. So those problems don't really have a lot of work to show. When we get questions like that, I'm not going to look at those and go, you didn't show your work. I think something like this, when they say find the equation of this line, if you've got an answer with no work, I don't know about that. I couldn't do this in my head. No way I could do this in my head. So here we should have some stuff written out, okay? All right, so that's what we have for today. So a couple things to remember. On Wednesday, so for some of you that's in a couple days, for some of you it's tomorrow. Wednesday we're checking out calculators, and I can check out, I don't know if I'm going to check out books, because here's the reason why. If we're going to switch over to our the new textbook, the online one, if I'm going to do that within a month, I don't want to have to collect all these books back. I really don't. So I think I'm not going to check out any books, and we'll just we'll have to use the online version. We're going to be stuck there anyway. I don't have enough books to check out to everybody. I knew it immediately when I started asking the question, and so for now we've got this online book, but we're going to be working out a different one later, and we'll just have to deal with that. What else was I going to say? Calculators, we're still doing that. So Wednesday, that's the number one thing I want to get to people, is graphing calculators. So no work tomorrow. We'll be checking those out. And I'll see you guys on Thursday and Friday. All right, we'll talk to you later.